Hello everyone, welcome to Refresh. On a beautiful Sunday we're recording this. It didn't took us too long, only half an hour to set up, but I think it's decent for the first time. Episode 1 of Refresh is going to be about time travel, and Refresh is going to be a podcast about expressing yourself and just debating and talking some interesting ideas, which are also classic in some ways, but also trending and never dying. So to start with, gonna introduce our guests for today. So top left corner, we've got a guy from coming from Brussels, Belgium, but parents are French and Spanish. I also think that there's something mythic about him because I think some of his heritage is from the Basque region, and he also talks to me about that. He's very versatile. He comes from École Centrale des Arts Métiers. He's a graduate school of engineering. He also is having outstanding initiative. He went with Erasmus to study at Universidad Pontificia Comillas. He's a guy with a lot of passion and determination. He wants to better the world, so he's done an MSc in sustainable design. Also has a very fine taste in music, and if you want to have a nice coffee and a croissant and read the newspaper in the morning, I think he's the best companion for that. Mechanical and sustainability building design engineer at Rumble. Guys, please welcome Pierre Crespin. How are you, Pierre? How are you doing, Pierre, today?
I'm good, guys. Honestly, happy to join this first session for this podcast. A bit try and error at first, but really cool. Really looking forward to get into this crazy topic, time travel. So awesome.
Yeah, man. I know you said when you heard the first is time travel, you're very excited by that. So I'm sure you've read plenty of books, and you can share all your knowledge on that with us today.
Some knowledge. Don't expect too much. I'm not an expert.
Sure. No, that's the point. Joining this podcast is not about being expert in a field. It's just being curious and maybe sometimes just ask the right questions and initiate thoughts. So next, coming from Bucharest, Romania, studied at the best college in the country, Colegiul Național Mihai Viteazu. He followed up with a degree in cybernetics, but that wasn't enough. He also went with Erasmus. He went to Orléans, at Université d'Orléans, to study econometrics and applied statistics. He is the person that shows the most proactiveness you've ever seen. His experience is ranging from banking, regulatory strategy to machine learning and data science. He's a present consultant at Deloitte, and is the guy you want on your side in every quiz game you play. Please welcome Vlad Teleaba. Hello Vlad, how are you?
You forgot about I'm great. You forgot about how many kilograms I weigh. Right now after the quarantine. In the left corner, I bring myself. Yeah. Thanks for the intro. I'm great. I'm looking forward to hearing your thoughts about today's subject and about future episodes.
Great. Thanks for joining, Vlad. I can't wait to hear your thoughts as well. So next, in the top right corner, we have the guy whose look and whose eyes, when he looks at you, your heart melts. He comes from Cittadella, Italy. He studied electrical and energy engineering at the Università degli Studi di Padova. He has experience also in France, at Marseille, working on power distribution systems. He values intellectual curiosity, diversity, and ethics. He's probably going to be the next impactful global leader in the energy sector. And at present, he's an electrical engineer at Ramboll in Manchester and a key member of the CIPSI Committee of Electrical Engineers in Manchester. Please welcome Marco Olivier. How are you, Marco?
I'm great, Caro. Really honored to be present today. Looking forward to the discussion. I have to say, I really should have made a note of your introduction for myself. That was really spot on, and I should use it.
Okay, good.
Next event.
I've missed the 255 pounds and 6'5", 3.5% body mass.
Yeah, that's not what matters now. That's not what matters.
Yes. Okay, so last but not least, our final guest for today's podcast. We've got the man whose CV is basically a book. He's a former student in computer science at École Polytechnique Paris. Also a PhD graduate at Telecom Paris Tech, studied machine learning and structured data, an expert in artificial intelligence and decision making, a research engineer in autonomous vehicles. Should I keep going? Yeah, let's keep going. Postdoctoral researcher in high-density cross behavior at Imperial College, present assistant professor at University Paris Sud, researching topics related to data fusion, perception, machine learning, and robotic vision. A very good friend of mine, and the oldest friend of mine from today, and a genius. Please welcome Emi Aldea. How are you, Emi?
I'm fine. I was a bit stressed at the beginning because I didn't know who the expert was on time travel, but now that Pierre said he read I'm gonna be the student today.
So that is sorted. Indeed.
Yeah.
Right. So now that we've made the introductions, let's jump straight in. So we're going to talk about time travel today. So let's start with your thoughts on time travel. I feel that recently there's not only recently, but there's been more TV series, more movies, more podcasts, more books. So I think the subject has a lot of traction. How do you feel about that? Any thoughts on time travel as a starter for 10? What do you think, Pierre?
I'd say it's a thematic that has been used and reused so many times, both in literature or like even in cinema. Like if you think about it, it's always been a bit special thing that like we all love, but it's very slippery slope in a way. You know, a lot of people have tried to talk about time travel, and sometimes it really doesn't work at all. But we have some good examples though, so that's cool.
Vlad?
For myself, I think on today's podcast I will play the role of the challenger to the ideas of other people who are a bit more familiar with the time travel. On myself, honestly, I didn't necessarily read books about this subject or watch movies about this. So I think today I would like to challenge what
that's good.
You are proposing or saying from the point of view of somebody, myself, who is looking at things with an intuitive perspective. Some of the time travel notions or theory is a bit counterintuitive. For example, the stuff that you
the grandfather paradox
about quantum mechanics, exactly, the theory of relativity, etc. So I would like to participate in the discussion as somebody who looks at things with
sometimes the challenger role is maybe the hardest one because you have to find the right questions. So yeah, looking forward to that, lad. Thanks. Marco, initial thoughts on time travel.
Yeah, I think I really resonate with what both Pierre and Vlad said. It's an interesting subject for sure. I also think that there's no an actual answer to it. So no matter how much someone could be an expert on the topic, I think it's still very open to discussion and feeling. So I think that's going to be interesting. I would say the experience I've got with time travel is limited to sci-fi movies I watched. I haven't yet experienced that in real life. I haven't experienced time travel, but that was one of the next step in my to-do list. So that's coming. That's coming.
Okay. So you
would be good to see what we say.
We're gonna come to that. I have a great question for you. Then I'm glad you said that. Emi, or initial thoughts on time travel?
Yeah. I don't know if it is really a topic that is for which I've read a lot. I wouldn't say so. So I have like a beginner experience for someone who had the opportunity to read a little bit more on it. So I think I'm going to discover it a little bit with you. I would say that I'm more of a challenger on this topic. I do have a couple of questions. So since you've contacted me at the beginning of the week, I had to think about it, at least while commuting.
Well, you see, Emi, I'm very glad you said that, and I'm going to put this out there. I think this is what this podcast is all about, right? It's a subject. Someone just mentioned it to you, and then someone invites you to a podcast or invites you to have a chat, and you don't need to do more than having a think when you're on the tube or on the train about it, and that inspires you. It makes your mind and makes your thoughts kind of start to come together and make you more curious. So I think this is what this is about.
So
to wrap this up a little bit, sorry, Emi, go on, go ahead.
So I think I might have a couple of questions which could be interesting, at least from the point of view of a beginner who could also have them.
Sure.
So I would be very happy to discuss this with you.
Sure.
And maybe
great.
You can
exactly. That's what I wanted to say. I think, Pierre, you're going to have a lot of work to do because we have a lot of challengers here that are ready for you.
No.
Yeah.
I don't know how you put me on the position of the pseudo expert.
Pierre,
I'm a challenger too,
Pierre, I know you very well. It doesn't matter what you say. We all know the truth, and we are ready for the answers today, Pierre. Right. Okay. So let's start with the grandfather paradox, because I think this would set the scene with some of the problems that maybe Vlad pointed out, that there are some counterintuitive things. So the grandfather paradox says that if you can time travel in the past, you could go back and kill your grandfather, which sets you in a loop. Your grandfather wouldn't then your parents wouldn't be born, so that means you wouldn't be born, which means you couldn't go back in the past to kill your grandfather, and that is not resolved, and that sets some causality problems, and the chicken and the egg problem. There are a few ways in which researchers and scientists try to resolve this, but I'm curious to hear how you feel about this paradox. Do you think it's a paradox that makes us believe that time travel is impossible? What do you think, Emi?
I think that, okay, if you don't think deeper, it makes it at least questionable, yes.
Sure.
But I mean, it is a very valid paradox. It's a very valid question, and either you say, okay, it does make time travel probably impossible or very difficult, or you have to come with a more complex theory which explains it, obviously.
So you feel that it doesn't necessarily discount it from the start. You feel that there could be ways we could look at this paradox and resolve.
Yes,
Okay.
yes, absolutely. But the fact that you can go back and then you can have like a loop influence on what happens on the present time, makes it really complex as a theory.
Anyone else?
Well, I think this paradox at least makes you think that you have to reach a conclusion. When you think about this grandfather paradox, you have to say, okay, if you would travel in time in the past and you would kill your grandfather, of course.
You have a bit of a problem.
At least it should make you go to the conclusion that under the same universe that we are living in, this is impossible. Okay, at least I don't know, if you kill your grandfather, the logic would be that you would disappear, you would vanish instantaneously because you would no longer exist or something like this.
And there will also be loads of things vanishing probably at that time.
Exactly. So we would already have noticed everything. So this brings us to the other possibility, the other discussion about parallel universes and what would be the implications of traveling to the past. Even if you wouldn't kill your grandfather, traveling to the past would change even minor things, and with the butterfly effect, it would have an effect in the present. So this means that this poses a big question mark about the idea in itself of traveling in the past. Either it's impossible completely, or we go to the discussion about parallel universes, and if you travel in the past, you don't really travel in the past, etc.
I saw you.
So this would be my intuition.
Sure. I saw you were nodding, Marco.
The challenger.
Because I was thinking on similar concepts, similar ideas, but I'd like to start from saying that you asked to Emi first if this paradox makes you think that time travel is not possible because of that. I would think time travel is not possible more based on mathematical assumption, rather than a mental experiment like this one we're doing. And then I was nodding to Vlad because I think there are two versions I like to think of about time travel. One is that is a loop, like time is a line, and then you can go back and modify what's happening further on the line, as you said, with the butterfly effects.
Right.
But I also like to think about time as a sum of many instants.
I was thinking about that when you said about this string. Yeah.
Each one of those instants then are kind of independent from each other. What happened in an instant, then it develops on its own. You want to call it his own universe or his own future. It's a bit personal, I think. So then when you decide to go back, you're not changing the instant after you left.
Very interesting.
You're changing just the instant where you joined.
Very interesting.
Came back.
So let me see if I understand this, and then maybe someone else wants to join. If I have a string, and this string has a line of events that flow, the problem first that we have here is that we don't know when they started. So this we are given with the fact that we have a string that at every point of it, let's say a millimeter or a unit, it has something, it has a story defined in it, and this string is time. Now, if we take the string and split it, so we take something and bring it back in time, then what that instance will do to the forward, it will change the future, but another future, because every point on the line moves ahead. So it's like a flow of water, and then imagine you spill some oil in the tube. It doesn't mean that the whole tube becomes oil. The water flows ahead, and then the oil goes ahead, and then what comes behind it is again water. So then if you put like some color, you go again and put some color, then it's some color. So you have this constant flow that loops and goes in a circle. Is that what you're saying, Marco? Is that correct? That you can?
Yes. But I also that's it. But I also like to think that in reality, once you close the loop and you come back, and then you changes the events that happen after you came back, this doesn't change all those moments in time that brought you to be where you were in the future when you decided to come back in time. That keeps going on kind of on a parallel.
Well, is it parallel or is it ahead?
Back.
Like, are you thinking, for example, if you now go back 5 years, are you saying, do I understand correctly, that if you do something after a year, you from the present also would have gone a year ahead, so that your past version would never catch up with you to change you?
Yes.
Because you're always 5 years ahead. So if the past version would kill someone, then you are 5 years ahead, so you'd still live with that person, but in the past version, things would be changed.
But then there's this thing, because we can just make assumption about going to the past, and are the two versions of us simultaneous or in parallel, or they exclude each other, whatever. But let's say that you actually, if you go into the past, assuming that you can, then in theory you could catch up with a guy who is 1 year in front of you because of the theory of relativity. So who has to go faster in this case? Who has to take the spaceship?
But
the old person or the new person? And if you travel fast enough, in theory you can catch up with the other version.
Well,
right?
If I'm thinking, if you travel slow enough, right? Because if you travel faster, time goes slower, right?
Yeah.
So
the other guy has to.
Exactly. So you go in the past. So then, if the guy ahead of you travels faster, then time goes slower for him, and then you catch up with him. Possibly, maybe you don't want that. But yeah, that definitely sets a problem that you can catch up.
That's what happens in the movie Interstellar, isn't it?
What happens in Interstellar?
Sort of.
I've just seen it recently, actually.
Because those guys enter an orbit of a black hole, if I remember correctly, or an orbit of a very heavy star, and therefore their speed accelerate a lot, and they get to travel to nearly the speed of light. So when they then come back from that system, this guy's daughter, which was very young when he left, now is even older than him, because in the meantime he has been traveling at high speed.
Yeah, exactly.
For himself, the time has slowed down, while for his daughter didn't. So then when he come back, it ends up that he sees his daughter dying, because she was older than him.
So I think.
By the way, sorry if I spoiled the.
It's a very good example of the time dilatation, like general relativity. Only thing though, in the movie, it's not the speed that leads to the time,
Correct.
Between the time on Earth
Correct.
and the time on the spaceship going at different speeds. It's the gravity. It's because they're just so close to a black hole. When gravity is so big, it also slows time. So to slow time, you either go to high gravity area or you go very fast.
True.
It's one or the other.
That's it.
Yeah.
I remember.
True.
Okay. So what I was trying to say is that if you go back 1 year, assuming that you can go back 1 year, and then you say it's not a problem because whatever happens with the other version of me is 1 year in front of me. Actually, you can run into problems in theory. So, and that is not an assumption. It's actually an algorithm to do it.
Well, just hearing out Marco and then Pierre on the relativity thing. Actually, you, Emi, mentioned relativity as well. I think it's worth pointing out here just the little bit that we know about relativity and kind of putting it out there. So Einstein worked on the theory of relativity in the beginning of the 20th century and made some very, very big steps ahead, improving our knowledge on this. Because before that, physicists and mathematicians had these two big problems, right? They had the concept of relativity, And we can have the example of someone, it's actually in the book of Relativity of Einstein, the example of the train and the embankment, where the guy on the train throws a coin, and how does the guy from the train perceive the trajectory of the coin compared to the guy from the embankment? In this case, when you're sitting on the train, you see it falling straight down in a line, but from the embankment should have like a parabolic shape. So that's the concept of relativity. At the same time, that was in conflict with the Galilean physics and equations and all the rules that were set for the motion. So, for example, that distance is speed versus time. And the contradiction was that the speed of light, without going into a lot of detail in the special theory of relativity which followed, the problem was that it concluded that the speed of light is different based on your perception. So the special theory of relativity, which was the first work of Einstein's, followed by the general theory of relativity, said that the speed of light is constant, regardless of your perception of medium or speed, which then implied and concluded that time is relative. So before we thought that time flows constantly, but then that theory, the special theory of relativity, proven that time is not constant. And now it's very well known, and watches and clocks are set, for example, at different heights compared to like on a mountain, compared to on the Earth. Time at very, very small differences, but runs differently because of gravity, so because of energy. In this case, the higher you are, the smaller the energy is, and also the faster you go, the time goes slower. So I would like to raise a question here, because I listened to a few podcasts on time. What is time? Because we're talking about time travel, but the concept of time is a bit mind-boggling, isn't it? What do you think, Vlad? What do you, I mean, how do you perceive time? How do you explain, how do you perceive it? What explanations do you give yourself to map it out in your brain?
Well, I think let's get back to intuitiveness. The most intuitive way to see time is a sequence of space movements.
Very smart way to put
it. Of changes in space dimension.
Mm-hmm.
This is the most intuitive way to see it. So changes in.
Vlad, you're saying that is intuitive, but I think it's actually very profound what you've said. Because the time was linked to entropy, and we know from the second law of thermodynamics that entropy always has to increase, right? Mm-hmm. Which kind of is, from what I understand, is what you're saying. Entropy meaning things are changing all the time. So that means there is a timeline. But does that mean
a linear timeline? Yes.
Okay, linear.
Because,
but
because this was implied that once things change, they don't come back.
Yes. Correct.
So, from the point of view of this intuitive perspective, how is time travel possible?
Yeah.
How is it possible in comparison to this perspective?
Well, sorry, Vlad, if I interrupt you. They don't come back unless you spend enough energy to make them come back. And now probably, if you want to make some, let's say particles go back through the line of time they just were going on, probably you need to spend an infinite amount of energy to make them go back to that way. That's why it's not possible. And I close the.
This is where the mathematics problems come into play, isn't it? I don't know if someone knows more on this, but I know that maybe Emi, you know a bit on this. I'm not sure. I know there are some mathematics problems that come into play because of the infinities. When mathematicians have to deal with infinite numbers in their equations, they have problems, and they're introducing sometimes some other infinities to solve the maths problems in there, and this is one of the challenges, I think, solving the maths of time travel.
Well, there are different type of infinities. There's the thing with the countable sets, uncountable sets, and so on. But what Marco said regarding the entropy thing, it is, I think it is widely accepted, the fact that you can locally decrease the entropy with a cost. Okay, you have to bring energy from outside that subsystem in order to decrease its entropy back again. So the question here is, okay, so if the laws of nature make the entropy increase, it doesn't mean that you cannot locally decrease it if you spend enough energy. But the question was, if you want to go back in time and you see the time travel problem, okay, as this battle with entropy, how much energy do you need? Maybe it's infinite, maybe it's not, or maybe there are circumstances in which it is not infinite. This is more of a question. This is a dilemma here.
So just trying to kind of recap what we've said so far. We've talked a bit about the grandfather paradox, coming back and setting the loop. We kind of mentioned the theory where we have that string of seeing time as a loop, and then Emi kind of posed the problem that time is relative based on your speed, which kind of introduced us a bit in the special theory of relativity. I think it's worth mentioning the twin paradox there related to the special theory of relativity, where you have two twins, which is Interstellar in a way. But
yeah, which we did.
We talked about Interstellar, so being at different speed or different gravities, as Pierre mentioned. I mean,
we'll call it the father and daughter paradox. We'll change it.
Yes. And I think now we're kind of, we asked ourselves, what is time? Vlad said that time is a sequence of space changes, and then we thought about entropy and second law of thermodynamics, and then I think here we start to mention the general theory of relativity, in which Einstein defines the space-time and the importance of gravity, setting space-time as a mesh, let's call it, to visualize it in 2D or 3D, and then imagining the experiment with the marble put in this mesh, which means that space-time, instead of a plane, modifies and changes the geometry of space-time. For us, it's hard to visualize it in 3D, but in Interstellar, again, that black hole modifies, and it's a sphere that modifies the way we perceive space. And I think here there are some explanations and some ways that scientists tried to explain how we could travel through time. One is the Tipler cylinder, and I thought about that because Emi mentioned, do we need infinite energy or not? So Tipler proposed this huge cylinder which warps this space-time, but that needs a lot of gravity concentrated to be able to warp it. And I know Stephen Hawking said something that you need the planet of Jupiter in terms of mass concentrated in something like a ball to create something like that, and infinitely long to be able to create it. Or wormholes, where you have this space-time, or you have the page that is curved, and then you can punch a hole through it with a pen and go from one point to another. Any thoughts on these theories? Like, sounds possible to you, or far-fetched and hard to believe it's?
Apparently, something that I came across was that for the wormholes to be possible, you would need a lot of energy just to keep the wormhole open, because the space-time would by nature try to close it. And so you would need something to keep it open, and that maybe already needs a lot of energy. So. But in theory, you could create one, but then you will have to maintain it.
Sorry, Carol, to me, the way you described the Tipler cylinder and the wormhole sounded pretty much similar. I'm not familiar with the Tipler cylinder, and I'm not familiar on how you create a wormhole. Can you explain a bit better?
I thought this is Pierre that should answer this question.
Of course, I directed you, but then you know better your guests. Of course, in this case,
Marco, I think, as you guys said it, to create a wormhole, you need a very, very, very large energy, and in this case, from how we perceive it, because there are these four forces in the universe as we know them. Maybe you can help me here. It's gravity, it's electromagnetic fields, and is the small force and the large.
The weak and nuclear forces.
Weak and strong.
Yeah, it's the
nuclear forces, right? And yeah, I'm thinking that with gravity, like a very huge concentrated gravity, which means mass, because we know that bodies attract each other based on their mass, so that's where the gravity comes from. Yeah, you need a very, very high density to create the wormhole, which creates the drop as we've described it in that mesh of space-time. And by creating that drop, you can then maybe manipulate the mesh to go from one point to another.
So what's the difference between a wormhole and a Tipler cylinder?
I'm not sure.
Okay.
I'm not sure what the difference is.
Sure
that's kind of maybe like a reading thing. To put that on the reading list.
Definitely.
Let's have a look.
It's interesting also because then, sorry if I skip a bit ahead, the next topic is black holes, and I just wanted to say it's interesting how nature in reality tends to have, this is my thought anyhow, it tends to have the energy necessary to create such a geometrical distortion in the space-time tissue. And as far as we know, those are the black holes. But I wonder if there are cases where instead a wormhole is created. I just think we never really detected one, I think, so far as I know. I don't know if you guys.
And like, if you think about it, if you had like, let's say, a wormhole in which like you could, let's say, if it was created by a black hole, like a lot of people thought that maybe black holes was like a door to something else. But that would mean that on the other side, you have what would be called a white hole.
Yeah,
that
which we never saw, isn't it?
It exposes. And we don't really know anything that does something like that.
Maybe that was the Big Bang.
Well, exactly.
I just looked at the Tipler cylinder up, and basically, Marco, I think what Tipler did was to create an infinitely long cylinder just to help his mathematics of trying to solve it, trying to do something similar to a wormhole, but basically created an infinity through the length of this and the very, very high speed of the cylinder to assist his maths in trying to resolve it on paper to prove that it is possible. And he kind of concluded that, okay, if we proving this is possible, then maybe something that's not an infinite length but close to it, disproportional relatively to something else, maybe can have like similar outcomes. But then Stephen Hawking disagreed with it because he said that you can't have infinities and you can't use it.
That's cool. And if Stephen said that, then we tend to believe him, isn't it?
Well, if you don't have any more thoughts on this, I don't know, Vlad, do you have any more thoughts on general theory of relativity, gravity, space-time, wormholes, black holes, Tipler cylinder, or this stuff? Or should we go to talk a bit about quantum mechanics?
We can go to the next topic.
I think it's just worth to mention that last year they pictured a black hole for the first time, and I think that is super cool. So if you don't know about it, Google it because it's really worth it.
Mm-hmm.
A super massive one, by the way. Check it.
I know they were trying to picture the one in the center of our galaxy, but I think the actual pictures is from a different one, which is a bit smaller but closer in distance, and the results is pretty much the same. And I think they did that at the very last minute. That's from what I remember reading last year, just because they were having some disturbances in getting an image of the one at the center. But don't take what I'm saying for granted. I think this is what I remember. Anyhow, it's really, really cool. If you look at the picture, you can look at it and get lost.
What I also know,
it does make sense though that like within our galaxy, it must be really difficult to see really our black hole, because there's all these stars in between.
Exactly.
And like it's super difficult to actually see a black hole. You cannot see it. You see what's around.
Exactly.
So it's easier to see like another galaxy.
And another thing I think is cool is that picture confirmed the mathematical models they made of a black hole before, without having a direct experience of them, which was also used for the movie Interstellar, which we keep coming back to this movie. But another example of where mathematical models have helped us to model a real event, basically. It's super cool.
I know I read something similar about black holes, that you can't actually see them because they attract light as well. Not even light escapes it, but you see what's around it as being kind of modified in certain ways by its gravity, and you see things that are disturbed around it. So you then assume that's a black hole there.
Yeah. There is also this effect called gravity lens. I don't know if you know this. The black hole that you were mentioning, that we took the picture from, you could see like a ring of matter going around, but the reality is that what was on top was not what was really on top of the black hole. It was what behind it, is that the light is bended due to the gravity, and it gives you that picture, but it's actually not what you see. It's slightly different.
And this is another way of proving the theory of relativity, where gravitational forces bends light, while bends the space-time tissue. And I think what you were mentioning before, Carol, is called the event horizon.
The event horizon. So, getting a bit into quantum mechanics, I think this is very interesting because it seems that it could potentially solve some of the problems that we ran into so far. And like a few subtopics that I could link with quantum mechanics and the way it tackles time travel, I think, are the parallel universes explanations, and some other explanations here I think are given, that like predestination. So what do you think about being able to travel in the past, but then not being able to change it? Then I have a view on this, and I have like an example, but maybe you can share your thoughts on this, because we haven't really mentioned this so far, haven't we? Being able to go in the past, but not being able to change it at all.
Yeah, one possibility on those things, I think, was that, like, yeah, indeed, every time you would go back in the past, you don't really come back into the same timeline. What you do is that you create a diversion and you keep on that one. So you can affect the time, but just on this new timeline. You're not affecting the timeline that you were coming from.
How cool is that?
Interesting. And also a bit scary, because it means if you wanted to change the past, but like in your own timeline, then it's impossible. You can just go in the past, create a new timeline in which you have this change that you want.
I think we definitely have to mention Schrodinger's cat experiment here. I know you've mentioned this yesterday, Marco, when we were talking about something else. the Schrodinger's cat experiment basically is an experiment in which you put a cat in a box, and then you have a trigger there, and then a poison that kills the cat. And then that trigger is based on, I don't remember exactly what it is in it, but it's some particle that will interact in a way to trigger the poison and kill the cat. And we know that the probability of that particle to do something was 50%, which means that we know that it could happen and the cat would die, or it might not happen, not trigger, and the cat would not be poisoned. And the question was, we put the cat in the box, what happens? Is it dead or alive? And quantum mechanics, because it's all based on probabilities, says that you have two cats. One is the one that lives, and one is the one that dies. So the cat is dead and alive, is 50% dead and 50% alive. And actually, you generate two universes, two timelines there, one with the living cat and one with the dead cat. And here, I mean, quantum mechanics is so beautiful in this sense. I think there's the quote that said, "The moon doesn't exist until you look at it," which is the idea of until you do an experiment. Maybe you can tell us more about this, Emi, because you're doing loads of experiments. And I think philosophically, I'd be really curious to hear your thoughts. Until you do an experiment, you don't know something is true. Even if it feels true, even if you've done the maths or you have a definition, you don't know it's true. What do you think about a priori conclusions and axioms in this sense?
Well, I have this problem every day in the lab, meaning that we are almost sure that something will work, and 99% of the time it doesn't work as expected, or it doesn't work at all. So yeah, absolutely. Now, even in all fields, in our field, image processing, computer vision, all that, you have half of the paper which is just the experimental section. You would say that we are working in a mechanics lab or a physics lab or something like that, and because everything has to be validated, and things became so complicated that you cannot just prove something and expect it to work as expected. Just because we are working with very complex systems. So
sure.
Yeah, just as soon as you leave the pure math environment, then you cannot trust the theorem anymore, because there are so many assumptions that you make. Some of them will not work, will be violated. They will not work as expected. So yeah, absolutely. I was not like that at the beginning. When you work in theoretical computer science, it's not like that. You don't have experimental section. You have the main section and then the conclusion. But in most fields that you can encounter in a robotics lab, it's not like this anymore. So if this was the question, yeah, validation is fundamental.
I'd follow up with the question, Emi, because so do we think the beauty of quantum mechanics, in a sense, then, is that it looks at small things because it tries to simplify the problem? You're trying to start with looking at a particle, the smallest one you can see or observe, and try to find its momentum and position. So start very, very simple with something that's not affected by complexity, and then understand what that's doing. And then quantum mechanics says you have no clue. You cannot tell at the same time what's the position of the particle and the momentum of the particle. You can observe the position, but then you don't know what the momentum is, and then the other way around. Is is this the beauty of quantum mechanics, the fact that it simplifies the problem between many other things?
Definitely. But the problem with quantum mechanics, I'm not an expert, so I followed a couple of lectures at some point during my curriculum here and there. But
you're an expert today, then. You are the expert today, then. If you've done a few lectures on it.
No, not at all. No. No, but I know people who are good in quantum mechanics, so this is why I'm saying that I'm not definitely the expert. The problem with quantum mechanics is that even if you isolate a system and you make things as simple as possible and as tractable as possible, it's really not intuitive. Everything is very counterintuitive in this topic. So this is why even 100 years after Einstein postulated something, it's still very important that you can actually conduct another experiment to check that it really has value. Otherwise you would say, yeah, the fact that we can do this during an eclipse or whatever, and we can still check again the validity is not worthwhile. It is, because you always question these things. This is why it is science. It's not just philosophy or spirituality. You can actually check and double check and triple check again and again, and it adds value each time.
What do you think, Vlad? Is the moon there when we don't look at it?
Is this another experiment or paradox of quantum mechanics?
It is a quote. I don't remember who said it. Maybe Bohr? I think Einstein said the moon should be there, and Bohr said that the moon is not there when you don't look at it. Well, maybe it's the...
So
Yes. So Einstein said, I like to think the moon is there even if I'm not looking at it. Challenging the Bohr's quantum mechanics perception of things.
I'm with Einstein here.
Okay.
But then about Schrodinger's cat, I have a question about this, let's say, experiment or paradox. Was this a way to demonstrate one of the paradoxes of quantum mechanics, or it was an experiment against some concepts of quantum mechanics? I'm not at all familiar with quantum mechanics, but the way you explain it, and I agree here, I cannot rely only on my intuitiveness, because these are concepts that are counterintuitive. But if the experiment tries to prove, based on quantum mechanics theory, that the cat is simultaneously dead and alive, is it maybe because some interpretation of these concepts is wrong, or maybe the theories?
Indeed, yeah. Does anyone want to follow up on that?
I mean, just me as an amateur on this topic. I have a really curious question about what did this guy want to prove with this Schrodinger's cat experiment?
He was not trying to counterproof something with this paradox. I think he was just trying to illustrate the fact that at a microscopic scale, you do not have a definite state for a particle. You have a superposition of states. So it's just like a mixture
of probabilities.
And actually, when you observe it, it is at that specific point that you collapse that superposition and you pick up one of those states with a certain probability. But if you don't observe it, then it's a superposition of different states, and this is why these guys were asking themselves, okay, if I don't see the moon, is it a superposition of it being there and not being there, or it's there all the time?
The same with the cat.
But does this mean, does this mean that quantum mechanics theory is applicable mostly to atom level or molecule level, but
Yes.
for things that we observe, like macroscopic level, classic physics is more
Appropriate.
is the only applicable, the only one applicable?
I think that's the
absolutely.
perfect
It's
way
just
to
like
put it,
with,
Vlad.
It's the thing it's just as with the tunnel effect. When it's like when you at the microscopic scale, you a particle can go from a low level position to another low level position, even if it means that it has to pass through a higher level position between the two. Okay, and the probability of it's like when you have a particle which passes through a wall. Okay? If we talk about a particle, the probability of this thing happening is really not negligible, and that we have tools which work like this. So we have microscopes which are based on this effect and so on. So it really works. It means also that in theory you could also do the same. You could go through a wall. You just with a certain which is not zero. You go against the wall and nothing stops you. Or your atoms go on the other side. But the thing is that you have so many atoms which should do simultaneously this thing, that in terms of probability, in terms of entropy, all that is just plain impossible. So there are a lot of things which are true at the atomic scale, but when you try to apply them to a macroscopic scale, the probabilities just go over the roof, and it just doesn't work. It doesn't mean that it's not true, but it's not helpful anymore.
But I find it crazy, that thing that you have to accept that both things coexist on a superposition, and that it's someone witnessing that then collapses that to one possibility. Is that actually that thing that someone observing a reaction will affect it? I still find this mind-blowing, and it's crazy.
Yeah, that's it, Pierre. I think that's the fact of observing the systems defines the results you take back from the system. And that's why until you don't, in reality, you measure it, you see what's the state of the system. But that's not in reality what it was, because before it was a probability of all those possibilities. And just the fact that you measure, you pick one, but that peak has been influenced by your measurement.
I think that's amazing, because I'm trying to link it with time travel. I was thinking about Vlad keeps saying he's mentioning his intuition, but I think he's explaining the things that I kind of the knowledge that I gained very simply. So, for example, quantum mechanics only work. I think Dirac has a formula for which he limits the application of quantum mechanics, and I know this it's a scale. You can do some check in terms of scale, and you understand if your problem is in the right scale for a quantum mechanics or not. So if things are too big, then probably you shouldn't apply quantum mechanics. You should apply classical physics. And makes me wonder if then, and I think people are doing the experiments with this, we should try to send very small particles in time first, or to experiment time travel with particles, then with people. Because how harder is it to put a human being to go through a wall compared with a particle? It's the same. It's the same kind of problem thinking.
Another thing interesting, not on the topic of time travel, but just in general information, is the entangled particles. So sometimes you have two particles that are linked. One might have a spin positive, the other has always a negative spin. and they constantly alternate, but they're always linked. And if you affect one, even if the other one is at the other side of the galaxy, it will immediately react
regardless
to
of the distance. I think they're called Alice and
Exactly.
Bob, the two particles.
Yeah, like Einstein used to call it like a ghost interaction or something like this. But yeah, entanglement, I think it's called nowadays. But
I think it applies only to the spin of the particles, isn't it, Pierre? It only changes, it's the spin that is affected.
Yeah, because like one rotates in one way, the other rotates in the other one. But they are always changing, but you know that they're always linked. If one is plus, the other is minus. And I was thinking, like, imagine if you had like, let's say, one of those on each of the planets of the solar system. You could, in theory, communicate, like in Braille, like tick, tack, tack, tick, tick, tick. You could communicate immediately without the delay that we tend to have from the light traveling all
which
the
is
way
time
there.
travel, basically, right?
Well, you could use
yeah, exactly.
You could use the spin as 0 and 1, and then you create a program, instant program that communicates.
You create a sort of Braille on a quantum computer to send messages to the other planet.
Fascinating. Yeah, I think so.
And I think they even did something, I think it was to like just a particle or something like that. They pulverized a particle on one of them and it got recreated on the other side, on the other particle. So they teleported a particle through that.
Awesome.
It's crazy.
So guys, coming closer to the end, I think I'd like to get some concluding thoughts. I personally feel that time travel in the future is doable intuitively, as Vlad says, because if we travel very fast, time would slow down, correct? So we could make something to be in a state where time goes very slow for that person, and then wake him up after 20 years. That person time traveled 20 years in the future, right? Like the guy in Interstellar. I think Interstellar, we should name this episode Interstellar.
Yeah.
So the guy traveled very fast and then comes back and then, oh, wow, I'm in the future, 20 years. However...
So you can only go in the future?
Exactly. I have a big problem with traveling in the past. And one of the big issues that I have with it... Vlad, do you know what that is? Because I think you've mentioned this sometime in the past. You know what I'm referring to?
I think... not sure. I think we discussed only about the grandfather paradox before.
I mean that if we would be able to travel in the past, we would have had some visitors already.
Oh, yeah, from the future, yeah.
But maybe we have. We just don't realize.
Well, that's it. That's an interesting thought.
I mean, I wouldn't be surprised if Elon Musk was a time traveler, because for what he has achieved, I cannot have a different explanation.
So they wouldn't tell us. So if they come back and...
Well, maybe in origin they tried. Everyone thought they were crazy. They were nuts. No one believed them. So then now they just stop trying. They come back and they just say nothing. They become rich.
Yeah, the thing is that if you travel back in time, it would be really, really frustrating to spend. Just think of how you lived. Maybe if you were in the 90s now, because sometimes I think about it. In the 90s I was at school and at high school, and you couldn't just read something on the internet, or you didn't have a phone, or you didn't have a computer. If you put me now to live in 1992, I would be like extremely frustrated.
But you'll be the man to create the internet.
Yeah, but I would still be very frustrated. I think that would be very visible. So that would be a problem. Yeah, it was just a joke, but yeah, people who come from the future, it would be difficult to.
So you're saying that's a way to identify them. If you see a person that is frustrated, it means he came from the future.
No, but like we tend to say, oh, well, if time travel could be possible, we would see people coming from the future. But maybe, yeah, they just don't want to come before maybe the year 2025 when they don't have internet and high-speed internet. So maybe that's it. We will start seeing them appearing soon, you know.
That's great. We got
maybe
some
they
answers.
only come back when there is a way for them to come back. So they will only come back when we invent the time travel.
Maybe.
Otherwise, they're stuck with us.
I think there's an explanation around that, isn't it, Marco? That from the time, so if time travel is discovered in 2030, the theory would say that you cannot go back beyond 2030. And that would be the starting point. And you can only go back from 2040 to 2030.
Wait, why couldn't you go back before 2030?
Because it wasn't invented before then.
You were mentioning that people from the future will only come to the past to a period where it has been developed, or they would get locked.
Yeah.
Oh, yeah, but theoretically they could go back to before. They just don't, because otherwise they don't have a choice to go back in the future.
Yeah.
The question...
And by the way, before we were talking about how much energy we would need to create that, the possibility to travel through time. Actually, that has been solved in the movie. What was it called? Back in Time? Where they travel with the DeLorean, the car?
Back in Time.
No,
Back to the future, yeah.
Sorry, Back to the Future.
Yeah.
He actually quantified these energies with 1.2 gigawatts that he takes from a stroke.
So it's problem solved then.
From a flash. Problem solved. We know that we have a lot of information. We just need to put them together.
Just need the budget to build it.
Exactly.
So what about photos? Isn't that fascinating? Or videos? Isn't that a way to capture time travel? When you look at a video, are you looking in the past?
Yeah, you are.
Are you capturing data somehow and then effectively are able to press rewind? What if you would record everything all the time?
You could watch, but you couldn't interact, isn't it?
Yeah, there is a Black Mirror episode like that, where people have chips implanted in their head, and their eyes have cameras that are constantly recording their life. And so at home, they can just watch TV, their past holidays from their own perspectives.
And then they get into some trouble. No spoilers, eh?
It's Black Mirror.
Yes. What if this would be VR and it would be in your brain, and then you would actually press rewind and you wouldn't even know you've been rewinded, but you would just feel you are in 1992?
Could be in the Matrix also.
But then you'd be stuck in doing over and over again the choices you did back then.
Maybe not. And then maybe you get into some trouble, because if your brain has changed through your experience, when you're put into that same scenario again, you would do something different. But then something would bug, I guess.
Interesting, yeah.
Yep. Well, a question for everyone. I'm really curious to see what you think about this. And I have my own opinion yet. Is time travel good? Let's start from top left, Pierre. What?
In which direction? To the past or to the future?
What you choose? You choose however you want to answer it.
Well, I think traveling to the future doesn't really pose a problem. You could just freeze yourself, wake up later on. That's fine. You're not really creating any paradoxes. But traveling in the past, if you consider one timeline that you don't split and affect, then it's better not to influence it. Or then the butterfly effect just will create a lot of problems and difficult to manage.
So you think good in the future not good in the past?
Dangerous, I would say, to play with time travel to the past.
Vlad?
Very dangerous.
I think, okay, this is one very good perspective that Pierre gave. I would add that in addition to being dangerous, time travel would not be ethically okay, because if somebody from the future could come back and solve errors or bad things that happen in the present, maybe this would imply that we can do whatever we want. We could screw up however badly we want, like create problems, wars, etc. Because somebody from the future will come to us and save us. Or so this would be an ethical problem with letting people think that
It's fine to do it.
Somebody from the future could.
Yeah, imagine the same. Like if some people from the future they say, "Well, you're gonna become an asshole in 10 years, so we're just gonna execute you now." It's also a bit unethical, right? Because you're not yet that person committing that crime. So it's like in Minority Report. I don't know if you know that movie, where police have access to visions of the future and they try to stop the crime just before it happens. But then is that whole ethical debate. Is it fine to put someone in jail for a crime he has not yet committed?
Exactly. And then, okay, we have to imagine what type of time travel, not only in the future or in the past, but also, would it modify the timeline as we already discussed? Or, okay, but let's say it would not modify the timeline. It would be unethical because it would give us the power to play like
God.
To experiment, exactly. Infinitely playing and experimenting based on past people's lives.
Mm-hmm.
So there would be multiple ethical issues.
Thanks, Vlad. Yeah, absolutely. I totally agree. Marco?
Yeah, guys. You said pretty much my thoughts.
But sorry, Vlad, same thoughts as Pierre for the future?
I think for the future it would, yes, it would. Maybe it would bring some positive things, or it would be at least I cannot think right now of the same ethical issues as traveling to the past.
And Marco?
Yeah. I wanted to say that I would have wanted to start my thoughts with saying time travel could be good, just to bring a bit of positivism in this topic. But I don't really trust the humankind that much with this type of technology, we want to call them. So even if it was first invented to do some good, I think that it will turn up or end up being quite bad. And it's basically for what Pierre and Vlad said, for all those theses.
Mm-hmm.
So yeah, I would conclude saying it's probably going to be bad.
Both future and past.
Yeah, I agree with what Pierre said. Past, definitely. Future, I don't know, because I can think of a person from today's day going into the future. It would be completely lost. I imagine even in 50 years from now, technology would be on a totally different pace from what we have today, and you would feel like your grandmother now. That's the issue. You could have a phone in your hands, but you don't know how to use it, so you cannot really do any harm.
Sure, okay.
But then you import an extra element in a system that was designed without that element. I don't know what consequences that could have. Probably bad.
Thanks, Marco.
Maybe the people from the future will just examine you so that they can know how were the people back in the 21st century, how dumb were they?
that might even help them though, because like if we could have a person from say 2000 years ago, this would help our research on history, and that maybe could be a good point, you see.
Exactly.
Emi?
Yeah, so I also agree. So with all you said already, the fact is that if you can go back into past, you are going to try to optimize it for you, but it doesn't mean that you optimize it for everyone else. And if everyone else has the same possibility to go to optimize it, then everyone will literally optimize the timeline.
Everything would be very optimized. It sounds like
it's not a process which converges easily, And
the future?
Yeah, you don't know if it's good or not. Now I was since you contacted me this week, I thought of this time travel thing, and I was thinking, okay, but actually there is a context in which time travel is maybe not that relevant anymore. Is what happens, now it's really technology. It's not something like science fiction, but that we are trying to understand more and more how biological neural networks work, and we try to replicate them, and people start to do. It's very complex. Okay.
Try to imitate the human brain. You mean?
Yeah,
on a
exactly.
computer.
So, for example, now they try to do this with small flights and all that. At some point, okay, and they really need a lot of power, and they realize that actually it's really, really complicated. These cells are really complex. Okay, but assuming that at some point you manage to do this with more complex brains like ours, and that actually our conscience is more or less in there, okay, and you are able to save your brain somewhere. Now you realize, or actually I realize, that a lot of this time travel issue is related to the fact that you have in your lifetime a limited number of choices that you can do. You can go to one high school, you can learn one thing, you have a limited time budget, and you have to fill it somehow. And time travel is nice because you can think of, okay, maybe there's a way to optimize it. But
or retry.
Absolutely. But if you are actually just a conscious, okay, and in this case, the fact that time is unidirectional, okay, is not that of a problem anymore, because it actually, even if it flows in a unidirectional way, it doesn't limit you anymore. If you are just,
if you don't die, basically, you mean?
Yeah, you don't die, basically.
Right. So if
if I manage to replicate my brain and save it, that brain is able to interact with your brains and have this discussion. The difference will be that the discussion that we have now would take place maybe in half a millisecond, and then we would do something else.
I see. So if the string is infinite, you can retry by just retrying, not having to erase it, because you have an infinite piece of paper. You can write as many times as you want. Don't have to erase it and write it again.
Yeah, you just need energy now. No, it's the energy the problem.
Is maybe memory a problem in this case?
Yes, probably. And maybe, you could say that you could have choices which are irreversible. You can still do probably some choices which are irreversible, but it will be less frequent,
Very interesting.
That is the thing. If you want to change your high school, for example, you just go and do another high school. It's not a problem anymore.
But Emi, this sounds to me a little bit like the matrix that Pierre mentioned, and maybe the example of your brain being put on the Neuralink on the computer and then just rewinding and replaying, because it's your consciousness, it's the simulation anyway. Like the world, it doesn't matter what the world is. Maybe the world, it isn't there. It's what you think happens, and then you rewind, and then you perceive everything again in a different way. It's not like changing something. You are playing the game. You are the game. So as we said, if your brain is changing and you'd go back and make a different decision, then your brain is able to also make everything else adjust and update the story. Like even other people would do something else because that's what you think they would do.
Yes, but in this case, the story is a little bit your story.
Yep.
You don't have really
it's a PvE. It's
interaction. Yeah, exactly. It's a personal story. So I think this is where the difference comes. When there are maybe some scenarios, okay, and this is one of them in which you are not so. Time really still flows, but it doesn't limit you anymore.
But Emi, what if but the world is changing, right?
Yeah.
So maybe the high school that you wanted to do, it doesn't exist anymore.
Yeah, it's true. Or it's not that it doesn't exist anymore, but maybe it's not.
Or someone died. Someone that you wanted to marry died, or. Well, if people in maybe in your definition, things don't die because they are consciousness.
No, I agree that they don't die, but the context changes all the time. So you would still have a problem, even if time was unlimited, because maybe you want to do something, but in a specific context. Yeah, I agree. It would still be a problem.
Very interesting thought, I have to say. Don't know if anyone else wants to say something on this.
No, I don't know. To come back to what you were saying with the PvE, it's not a PvE, it's more like an MMO, right? So it's like you're all in a simulation environment, but all these individuals interact in that one. So it's not just your own perception that changes all the reality around you. It's also your interaction with other individuals.
Maybe for some people that don't know the gaming slang, the PvE means that you're playing a game which is a single player game. So it's pretty sad if that's the live game. Everything else around you is just it's a single player game. Right. My opinions on if time travel is good is a strong no, and I feel like this both for the past and the future. And Vlad really challenged me when he mentioned the ethics, because I think that's right. But for me, I think for the individual, it can be unimaginably painful. Life is so beautiful because it's a one-off. And when you play a game on the computer, you can press restart, and after a point you delete the game. All the time you delete the game at the end. And after some time you get bored because you've replayed it. So knowing that you can replay life, I think it's horrible. Because as you've all said, right, it doesn't matter. Nothing matters anymore. You go back and do again. And then going in the future, man, I would never do that. Imagine what you can see, and imagine spoiling everything. Like, how can I go see it and come back and then everything is spoiled? No. What's the fun?
Well, you could just go one way. You could just go in the future without coming back and keep going forward.
Ooh, that's interesting.
You don't have the possibility to come back. You just can go like 100 years in the future, but it's a one-way ticket.
That can be interesting because you get to see a lot, right?
Exactly.
But painful. You get to lose a lot as well.
Yeah, because it's very exotic. For us already, it's weird to go to the other side of the planet. Well, imagine different time scales in different eras.
I mean, there is a Romanian novel by Petre, Ispirescu, Vlad and Emi surely know it. It's called Youth Without Being Old and Life Without Death. And we all read it when we were young. And it's very simple. but I've reread it recently, and it's so true and so painful. When you don't age and you don't die, you're gonna lose everything you really care about. And I think it is similar with Interstellar, right? When you get to see your children aging over you or even dying. So yeah, the story is about a king that traveled through time very fast on the horse, and then came back and no one was there anymore. So yeah, I don't know how fun time travel is, but maybe we can, if we figure it out, we also solve the ethical problems and these things that, I mean, for me, don't compute at the moment. Marco, bring the positivism back now.
I'm trying, but you set me in a very difficult position here. I think the positive now is that we don't have time travel.
There you go.
So
there you go. Okay. Emi, was there anything else that you wanted to mention? Because you said you had a couple of things. I don't know if you managed to touch upon them.
No, it was only that this last thing that I said, that if we assume that we kind of are able to transfer our conscious and keep it in an indefinite time somewhere, then the fact that we cannot time travel becomes, less of a constraint. But I didn't think about what you said, that, it's not only the fact that you can do something, you can do this and only do that and so on, as much as you can, but a lot of experiences also depend on the context. And you cannot control all the context, you can do some things, but not with the people that you want and so on. So yeah, it's
great stuff.
Even in this case, it wouldn't solve the problems that in theory could be solved with time travel.
Cool. Right, so we're heading rapidly towards an hour and a half. I think that's a good time for the podcast for now. It was the first time. It was a bit of an experiment to see how it goes. So I've definitely learned a lot from how it went. I hope you guys enjoyed it. Thanks for coming on. Gonna do a quick recap of what we discussed today. Maybe we could have been a bit better at organizing it and make it feel useful. I don't know if it felt very useful, but just food for thought. We generally discussed about time and what is time, and if time travel is possible, if we think it's possible to travel in the future or in the past, and if time travel is good or bad. So these are some questions that we can reflect upon. And then said that we can maybe tackle time travel through thinking about the special theory of relativity and the speed of light. And if we can travel very, very fast, then maybe yes, we can time travel. And then the general theory of relativity, so play with energy and gravity. So through gravity, big gravity, we can maybe change space-time and create a cylinder or wormholes or a black hole through which we can go back in time as well. And then thirdly, about quantum mechanics. So maybe we can't time travel, but small particles can, and maybe there can be parallel universes, and maybe we are all cats, and we all live and die at the same time, and talked about Schrodinger cat's experiment. I would also like to get some of your thoughts, guys, on the podcast in general, on Refresh. So we're going to start this time the other way around, from Emi going to Pierre. Emi, what do you think? Where do you think we can take Refresh? What do you think it's a good format for it, and how can we bring the most value with this podcast? I'd be curious to learn something from how you felt and what you think.
I was more of a theorist a couple of years ago. Now I'm more of an experimentalist. So I think we have to try.
Okay.
That's the most important thing. You cannot really predict how things can go very well. I would say that it has to be it has to be at least enjoyable for us. If the discussion is enjoyable for us, I think it can be very interesting.
Right.
That's the most important thing, and I found it really interesting. I didn't feel the time passed by, and I think if we are not, most of us at least are not experts in this field. It is enough if one of us knew something more interesting or read something interesting, so the discussion can fire up a little bit. I think it can be interesting for everyone. We don't have to be rocket scientists in order to find this discussion at least novel from some point of view. So yeah,
sure.
I think it could such discussions could be interesting for everyone as long as they have a bit of time.
Right. Thanks, Emi. Marco, what can we do with the refresh?
Yeah, I think I'd like to follow up on what Emi said. As long as it's fun for the people that are in the podcast, in this case us, I think it's already a win for us. And I found it very refreshing.
That's good.
I don't want to catch up on the name of the podcast, but I think you guys are all very smart and all open-minded. So the discussion is interesting, and there have been different points of view.
Not biased.
I think you guys are all biased. No, me and Caro were having a discussion yesterday on this bias or less. But anyhow, so yeah, I think it has been really interesting. And with regards to where this will go, I think it's interesting that we don't know where this is going to go, and then we leave it open and see what's going to happen.
Cool, man. Thanks for that, Vlad.
I think it definitely was very interesting for all of us, and I think we are all we have some things in common, but we are all also diverse in a way. And if it's interesting for us, it means it's interesting for a diverse audience, because I think we could represent a different typology of people. So let's try to find interesting subjects for the future.
Thanks for saying that, Vlad. This is a perfect time to call out all the ladies and successful women out there that want to join the podcast, because they were a bit shy to join the first episode, but hopefully this is now a good incentive to bring some women on the podcast as well. I think that would be good.
Zoom on Marco's eyes now, Carl.
Oh yes. yes well done, Emi. You see how
I don't want to be a part of this.
exactly. Oh. Pierre, follow up on that one.
Yeah, I mean, I don't know really what I can add on top of this, but it's been really interesting. You're right, we are all from different a bit backgrounds, well, mainly scientific still, but like from a bit diverse, some diversity. So like we all have a bit of different interests that we can like find and bring interesting stuff all from our experiences. And like as long as we find like good topics that interest all of us, we probably can keep this thing going. And every time I've like, look, it's been an hour and a half. It's passed quite quickly, to be honest. So good stuff. Looking forward for the future.
Nice. Cool. So I think we're gonna wrap it up there. Thanks for coming on. Thanks for taking the time. We've got some other subjects lined up already, and I've got some of my friends voting on what we can discuss next. So some good candidates are game theory and the prisoner's dilemma, or about social status, playing the life game, or the modern era and the Big Brother effect. So I would be very glad to have you rejoin the show at some point in the future. get refreshed, and also hopefully to get some more guests joining us, and have a nice remaining Sunday, and keep in touch, guys.
Thank you.
Bye.
Thanks, Carol.
Thank you, Carol.
Thank you.
Bye.
Bye.